In this video, will teach us how to calculate ERA. ERA is a baseball statistic. ERA stands for earned run average. It's meant to measure a pitcher's effectiveness. Essentially, it's how many runs would a pitcher give up if he pitched the entire game. So if he pitched an entire 9-inning game, how many runs would the other team score? Now, this rarely happens, so we have to use this average to kind of project if someone were to pitch the entire game. So obviously the object of the game is to score more runs than your opponent. So the lower the ERA, the better, right? The pitcher is preventing other teams from scoring runs. The earned runs part is also key. Earned run means that runs that are allowed by the pitcher giving up hits. So those are considered his fault instead of mistakes from his teammates, such as errors, pass balls, things like that, that can allow the team to score otherwise. The formula for ERA is simple. You take the amount of earned runs that the pitcher has allowed, divide it by the innings pitched, and multiply it by 9, because that's how many innings are in a game. So in our example here, we have pitcher A, who has allowed 15 earned runs in 30 innings. So if we want to plug that into our formula, we can figure out what his ERA is going to be. So we have the 15 earned runs divided by the 30 innings. Take that number, multiply it by 9, and you end up with 4.50. In our case, ERA tends to be reported to the 100th place, so you're going to want to include that 0 at the end. So essentially this is saying this pitcher would give up 4.5 runs per game if he pitched the entire game. Obviously, a half a run is not possible in baseball, but it is an average over time. So pitcher B, he has allowed 8 earned runs in 26 innings. So we take the 8, divide it by the 26, multiply it by 9, and you end up with 2.769 and going on, but as we said, we kind of round to the 100th place, so we end up with a 2.77 ERA here. What this tells us, at least for this sample size and statistics, is that pitcher B is probably slightly better pitcher than pitcher A. He only gives up 2.77 runs per game, whereas pitcher A would give up 4.5. So that's a quick tutorial on how you calculate ERA. Again, it's a very simple formula of earned runs divided by innings times 9.